Hello, everybody. My name is Iqbal Khan. I am a technology evangelist at this company called Alachisoft. We're the maker of NCache, which is a .NET distributed cache. Today, I'm going to talk about how you can scale .NET apps with distributed caching. This talk is not about NCache, although I will refer to NCache, but the main purpose is to educate you about what the problems are and how you can solve them with caching. I prefer to have a more interactive discussion, so please feel free to stop me. Just raise your hand, and I'll be more than happy to answer your questions. And I think we'll get started so that we can get this thing done. Okay. Just for completeness purposes, I'm going to get a few of these. Just one sec. I prefer to stand. I have this thing. Okay. Just for completeness purposes, let's get over a few of the definitions. I'm sure you know them already, but let's first define what is scalability. Scalability is not high performance. High performance would be something if you had 5 users, you have really good response time, that's a high performance. Scalability is if you can maintain that same high performance under peak loads. So if your application does not have high performance with 5 users, then you have other issues, more than we can solve here. So. Second, what is linear scalability? Linear scalability is more of a deployment definition. When you deploy your application in a multi-server environment, let's say if you have a load-balanced environment, your application is linearly scalable if you can just simply add more servers to get additional transaction capacity. So if you had 1,000 users with 2 servers, you add a third server, you get, let's say, 1,500 users, and then as you add more servers, you get 500 users each. I'm just saying hypothetically, but that's a linear scalability. If you can achieve that, that's the goal, because then you never run into issues, for which I'm sure you're here to address. Non-linear scalability is just the opposite of that, which is that you've got an application architecture where you just can't buy more expensive hardware or more servers to solve that problem. You have some fundamental bottlenecks. So as you add more servers, your application, for a certain time, the performance or the transaction capacity goes up. But after that, it actually slows down even if you add more servers. So you definitely don't want non-linear scalability. What type of applications need scalability? These are usually server-side applications. These are web applications, ASP.NET. These could be web services, WCF. These could be the backend for any IoT applications. We have a lot of different IoT devices talking to some sort of a backend. This could be big data processing applications, although big data processing is more of a Java activity. .NET is not, because of Hadoop, .NET is not very big on big data processing. But if you were doing big data processing, you would definitely need to scale. And any other server applications that don't fit into this category. I mean, you may have a lot of batch processing. If you're a large corporation, you may have to get a certain number of things updated by midnight or by before the next business day. And as you have more and more customers, you have millions and millions of customers. You of course need to scale that. So even those back-end applications, one good example could be that customers are, your bank and the customers are transferring funds from one account to another. That is usually processed in the back end in a batch mode at night. So you have to contractually get that done within a certain time period. So all of these applications, if they don't have scalability, you have major problems. And what is the scalability problem? The application tier, fortunately, is not where the problem is. If you have most of these applications, the application tier, you can add more servers. There's no big deal. It's the data storage that's the problem. And when I use the word data storage, I mean relational databases, mainframe legacy data. That's where most of your data resides. And they're the ones who cannot scale in the same way that the applications do. Now, NoSQL databases exist for one of the use cases is to scale. But the problem with NoSQL databases, and again, we have a NoSQL database of our own called NOSDB. It's an open source database. So the limitation of NoSQL database is that you just cannot move all the data to it, because they require you to move data away from your mainframe or your legacy or your relational databases, which for a variety of reasons, maybe technical, maybe business, you may not be able to do. So the relational databases are going to continue to be your main master data source. There are a lot of use cases where you can put a lot of the new data in NoSQL databases. And when you do, then they resolve the scalability bottleneck. But majority of the cases, you can only do that for a subset of your data. Majority of your data still needs to stay in your relational databases or in your legacy mainframe data sources. So whatever problem you have to solve, this scalability, you have to solve it while continuing to work with relational databases or with your legacy mainframe. And that's where a distributed cache actually resolves that problem. It allows you to continue using your relational databases, mainframe data, while removing all that bottleneck. So here's a picture. If you had, if these are your relational databases, legacy data, you can put a caching layer in between the application and the database. When you do that, what happens? You start caching data that you're going to use frequently. And about 80% of the time, you don't even need to go to the database. And the cache, because it's a distributed cache, you can add more and more servers. It scales in the same fashion as the application tier. So you have a minimum of 2 cache servers here. And then you maintain a 4-to-1 or 5-to-1 ratio between the application tier and the caching tier. Now that ratio can change depending on the nature of your operations. If each of your, let's say if you had a web application, and for every user click you do hundreds of cache calls, then of course the ratio would change. But most of the time you don't make hundreds of cache calls. A typical cache server is just a low-cost server. It's a web server type of a configuration, dual CPU, quad-core type of a box. It just has lots of memory. Lots of memory means 16 to 32 gig is pretty standard. More than 32 gig, you usually don't have to do, although we have many customers who go up to 64 gig. But we recommend that instead of having a lot more memory in each box, just add more boxes. And the reason is because the more memory you have in each box, the more powerful processor you have to have, and then your box is starting to look more and more like a database, which is not the intention. You want to keep this as low cost as possible. Now, a distributed cache is an infrastructure that you want to put for all your applications. So just like you have a database, which is pretty much a common infrastructure, the new best practice is to have an in-memory distributed cache. It's also called an in-memory NoSQL key value store. And have that as part of your infrastructure and architecture applications, so you're always going to this store. So you check the store before you go to the database. Once you have that infrastructure, then all your applications automatically become scalable. So you never have to worry about the databases becoming a bottleneck. And the biggest problem with scalability or not being able to scale is that that's when your business is doing a lot of activity. You have a lot of, let's say you're an airline and you just did a special promotion for Hawaii. Everybody's logging into your website on, I don't know, Wednesday to start to do your to purchase tickets. So they're going to search for flights and they're going to buy tickets. And you've got like 5 times more traffic than you had before. And suddenly the site slows down. Maybe it crashes. And it can crash, of course, if your database gets overwhelmed. But even if it just slows down beyond acceptable limits, the cost to the business is very high because people will just leave. So you really need to make sure that you plan for scalability, that you never have that situation where your business wants to do more activity, they're able to generate business, but you're not able to process within the application. And if you have the right infrastructure, then you'll never have that problem. Any questions on this so far? I'm just setting up the case on why you should use distributed caching, what problem is solved, and then we'll go into the details of how you actually use it. A typical, in addition to having more memory, you have usually, as I said, dual CPU quad-core configuration, 2 network cards, 1 gigabit or more each. In case of NCache, these are Windows boxes. In case of Redis, these are Linux boxes. Depending on if you have a .NET or Java application. My focus here is .NET, but for Java, you also have distributed caches. They call them in-memory data grid. On the .NET side, it's called a distributed cache. Okay, so now that we've kind of built the case on why you need to have distributed cache as part of your best practice infrastructure, both from an IT perspective, but more importantly from a development perspective, you want to architect the application. The first question that comes to mind is, well, how do I use this cache? What are the use cases? Where do I use them? I mean, I know what type of applications I'm going to use them, but what type of data I'm going to cache? So there are 3 main categories. Number 1 is what everybody understands, which is application data caching. So in application data caching, you're caching data that exists in your database. You're caching it, that's what we just talked about. So when you do that, you're actually creating 2 copies of the data. One is in the database, which is the master, and one is in the cache, which is the temporary copy. When that happens, what's the main concern? What could go wrong when you have 2 copies?
Out of sync.
They could get out of sync. In fact, that is such a major fear in people's mind is that most people, when you ask them, what do you use caching for? They say, well, for read-only data. I can't take a chance with my transactional data, with data that changes. Because what if that goes wrong? What if my customer withdraws that money twice from that same account? Then what's going to happen? Well, if you cannot cache transactional data, then the value of a distributed cache declines quite a bit because reference data is only 20%, 30% of the data. 80% or 70 to 80% of the data is your customers, your accounts, the activities, your transactional data. The data that changes every maybe 30 seconds, every 1 minute. Data that you may be able to keep in the cache for a very, very short time. So if you're not able to use a cache for transactional data, then you've really restricted yourself. So a good distributed cache must ensure that the cache and the database are always in sync. So that once you have that comfort or that peace of mind that the cache is always in sync with the database, you can cache practically everything. And when you do that, you really see a lot of the gains. And I'll go into a lot more detail on that. The second use case is when you have an ASP.NET application, there are certain ASP.NET specific things that you can cache. And the nice thing about this category is there's no programming needed on your part because Microsoft has a framework where a cache will just plug in. Number 1 is the session state. Every ASP.NET application has to have session state pretty much. Some people specially program not to use it, which is not a good idea. You should use a session. It makes your life a lot easier. A session is a very good candidate for caching because if you store a session in the database, you run into the same problems that databases are not designed for storing blobs, which is what a session is. So the performance is really slow. And more importantly, the scalability just goes away. For the same reason that you want to do application data caching, you want to put the sessions also not in the database. You want to put them in the distributed cache. The second is a view state. If you are not using the MVC framework, if you're still on the old ASP.NET framework, then view state. For those of you who don't know what a view state is an encrypted string, which could be as small as 100 bytes, or it could be hundreds of kilobytes. That is generated and sent to the browser, only to come back when you do a postback. So it's a pretty expensive trip. It, of course, slows down your performance because a lot more data is going, and also increases your bandwidth costs, because when you host your application, the pipe above this is not free. So when your customers access your web application, you're paying for the bandwidth here. So a view state, when you multiply that by the millions and millions of requests or the transactions that your users or customers are going to make, it's a lot of extra cost that you don't want to incur. So that's a very good candidate for caching. So you cache it on the server end, just send a small key. The next time a postbat occurs, the key comes back, and before the page gets executed, the view state is fetched from the cache. The third is the output cache, which is another part of ASP.NET framework, that if your page output is not changing, why execute it the next time? Because every time you execute the page, it's going to consume CPU, memory, and all the other resources, including your databases. So it's much better to just, return the output of the last execution. That could be the entire page, or it could be part of the page. So for all these three, you just plug in a distributed cache without any program. And I'll show you that. But the nature of this problem is very different than the application. In the application data, we had 2 copies of the cache. Of the data, right? So the issue was synchronization. Here, you have only 1 copy, and that is being kept in an in-memory store. So what's the biggest concern when you keep something like that in an in-memory store, and that's the only copy?
It becomes unavailable if the cache runs out of memory?
That too. Or if any server goes down, you just lost that cache. So for any of this to be stored in the cache, just imagine that same airline that I just went through, and I spent half an hour finding the perfect airline combination, and I'm just about to hit submit, and the session is lost. Not a good experience, because the web server just went down. So for this, how do you solve that problem when you have an in-memory and you have that concern?
Redundancy.
You have redundancy. You have more than 1 copy of the data. So a good distributed cache must allow you to do data replication. Without data replication in an intelligent and high performance manner, your cache again becomes much less useful. The third use case is something that most people don't know, or it's starting to become more popular, is that you can use, you have this very scalable in-memory infrastructure. You can use it for runtime data sharing through events. It is sort of like a messaging, but a much simplified version of it, and it's in a single data center type of an environment, where you can have multiple applications use the cache as a way to do pub-sub type of data sharing. So one application puts something in the cache, fires an event, and the consumers who are interested in that data receive that event, and they can go and consume that data. So instead of putting that in the database or putting that in a MSMQ type of a situation, which has its own purpose, a cache is not there to replace MSMQ, but in many situations, it's a much simpler and especially much faster and more scalable infrastructure to do event-based data sharing. So if you have a need where you have multiple applications that need to share data with each other at runtime, that you should definitely consider this as a feature, very important feature.
And would you say that's the cache clearing model as well then?
Depends on the use case. I mean, in each use case, you have to take care of the fact that the data has to be cleared from the cache. Even in these 2 case, and I'll talk about that. There are different types of mechanism where you can clear the cache. Any other questions up until now before I dive in?
Regarding the ASP.NET session state, I've run into a problem with that before, where when you store something in a session state, it's a complex object, right, that has nested properties, and those are also objects. Even if you mark it as serializable or whatever, those properties become null when you pull it back out. So is the answer there, just keep it flat, or is that just, have you ever had that problem?
Actually, that's more of a serialization issue that you need to make sure that your object is serializable completely. If you can do like in case of an NCache uses the .NET binary serialization. We also have our own custom serialization called compact serialization, which is faster. But in both ways, if you can just take that object and just do a binary serialization and then deserialize it, if that works, then the cache will also work. So that seems more like a serialization issue than a caching issue.
It was really puzzling, but I'll go and check it out.
If you're using generics, for example, then you cannot serialize the object unless you instantiate it. So you have to instantiate. Everything has to become a concrete type for it to serialize properly. No, you have to instantiate it with everything, because serialization works on concrete types, not on generics. And there are a lot of, if the code has generics, you have to create an instance of that object and then serialize it. Okay. Let me quickly, I'm just going to quickly show you the ASP.NET caching, how you do that. It's very, very simple. And I'm going to actually use, sorry. So I've got some sample code. So for example, if I were to, so I have this ASP.NET application. All you have to do is go to the web.config. In case of NCache, and again, it's going to be pretty much the same for all caches. The first thing that you have to do is add an assembly. So this assembly is the session state provider. So ASP.NET Framework has a session state provider interface that a distributed cache has to implement, and NCache has implemented it. And this loads the assembly into your application. So once you've done that, the next thing that you have to do is go to the session state tag. In fact, and make sure that the mode is custom, and the timeout, make sure is whatever your timeout wants to be. In case of NCache, then you just put this line. Other caches have similar type of information. So you just have, in case of NCache, all you need to do is make sure that your cache is named. And I'll actually show you what that means. But with just this much change in your application, you can basically start storing your sessions. So you make that change in every web.config in the application tier. Of course, you make sure that a cache exists. And then once you've done that, you can actually start to put sessions in the cache.
Server farm will, if your session starts on one server and it comes to the next other server, will the sessions share?
Yeah, exactly. That's the whole purpose, is that, when, oops, sorry. Got it. So if you see this, because this is a cluster, in case of NCache forms a TCP-based cluster. So these servers know each other. So they synchronize with each other. All the updates are synchronized throughout the cluster. The replication has happened automatically from one server to the other. So there are different replication strategies. The most common is where it's like a RAID disk, where every data is copied only to one other server and not to all the servers. So that way, you don't do extra replication. You know what?
The servers up on top there, if you have two different servers talking, then the session on the first guy and the next transaction comes on the second web server and hits NCache, it will retrieve the same. I'm assuming that's
Exactly. In fact, when you do this, these become stateless boxes. There's no state being maintained on the web tier, on the application tier. So you can bring down any server without losing any sessions. So that's the other good part.
Follow up. I think I know what I got confused. I was talking about server session state, like the stock. So here I see in your config example, you're using NCache instead.
Exactly.
So this probably has better support for the serialization.
Much faster. In fact, as soon as you plug it in, you'll see that it's almost 10 times faster because it's all in memory. It's a key value store, so it's very, very fast to access. So the web servers become stateless. You can actually bring any of them down for maintenance, for upgrades, for patches, and your application continues to work. This is the only piece. So this is a redundant, highly available infrastructure you've incorporated within your deployment. And that allows you to make sure that these sessions are replicated. I'm going to actually, let me show you what a distributed cache looks like, and that way the further conversation is going to make a lot more sense. I'm going to quickly show you a cache cluster. So, for example, I have these, I've got these Azure VMs where I've got demo 1 and demo 2 are my cache server VMs. And demo client is the application server. So that's the client. A cache client is your application server box. So I'm going to, and I have logged into, let's say I've logged into demo client. And I'm going to use this, in case of NCache, and again, I'm going to use this tool called NCache Manager. It's a graphical tool, lets you configure the caches from a single place. I will come here and I'll say create a new clustered cache. All caches are named in NCache, so I'm going to name my cache demo cache. I'm not going to go into any of the details of these properties. I will pick my replication strategy to be partitioned replica. And I'll pick an asynchronous replication. I'll do my first cache server. I'll do my second cache server here. So I'm going to build a 2-node cache cluster. I'm just going to pick everything. So this is that's the TCP port on which the cache cluster is formed. You can change it if there's a port conflict. I'm going to specify how much memory my cache server is going to use for cache. I have it as 1 gig. Of course, yours is going to be a lot more. So for example, here, let me quickly show you what this means. I'm just going to go to this part. So think of this as a cache server, and this as another cache server. So partition 1 exists here. Partition 1 is essentially a collection of buckets. Partition 2 has got its own bucket. So in case of NCache, there are about 1,000 buckets that get distributed between how many partitions you have. Every server has one partition. And every server, the partition is replicated on a different server. So if you had 3 servers, you'll see that partition 1 is backed up here, partition 2 is backed up here, partition 3 is backed up here. The replicas are not active in case of NCache. They become active only if the main partition goes down. So what I'm specifying there is the size of a partition. So in case of partition replica, if I specify, let's say 1 gig here, it's going to actually use 1 gig for the partition, 1 gig for the replica, so a total of 2 gig. So if you have, let's say, a 16 gig of memory, what you want to do is leave about 2.5 gig for the operating system and other processes, and the rest you can use. So for 16 gig, you can easily use 13 gig, so do a half and half, so it's a 6.5 gig partition size. And of course, you can have 32 gig, and again, you leave 3 gigs out, and you have 29 gig, half and a half, 14.5 gig partition size. And then as you want more storage, instead of adding more memory, just add more servers, because it's easier to manage. It keeps things much more scalable. So I'm going to just hit next here. The next is my eviction policy. I'm not going to go into those details. So, and I'm going to now add a client node. Once I've done that, I'm going to start a cache. I'm going to start a cache. And I wanted to show you this part because that's what's going to make sense about the rest of the talk. So it's starting these two cache nodes. I'm going to so I'm going to open up a bunch of monitoring tools, and I'm going to actually run this tool called stress test tool. It's a command line. It's a console tool that actually starts to do activity on the cache. Now, this is like it's simulating your application. So, if you look at it, your application is putting sessions in the cache. So every session is one object. So you're adding. So the cache count is got 177 on this box, 170 or 235. So it's going to be almost even, and then it's backed up onto a different. This one is backed up here. This one is backed up here. So as you can see, the replication is happening automatically. Your application does not have to worry about. All you did is created this cluster, and on the application tier, you just modified the web.config. And everything else happens automatically. You can, of course, monitor this stuff, but the cache is named. So in our case, I named the cache as demo cache. You can name it, in fact, you can have multiple caches. The most common configuration that we've seen with our customers is that they have 3 caches. One cache, they will call it, let's say, object cache. So it's their main transactional cache. One cache, they will call it session cache. So they'll put all the sessions in that cache. The third cache, they'll call it reference cache. So they'll put more of the reference data in the reference cache. And the reason they create a separate cache for transactional data versus the reference data is because for reference data, you want to use this feature called client cache, where you want to cache. I'm actually jumping all over, so please forgive me if I'm confusing things. If you have reference data, actually let me step back one more. Prior to having distributed caches, people had this ASP.NET Cache object. ASP.NET Cache object was a local in-proc cache. It was within the application process, super fast, right? If you're keeping stuff on your own heap, nothing can match that performance. As soon as you go into a distributed cache, it's an out-of-process cache. What people don't realize is your performance actually drops. We've got many customers who initially get baffled and they say, well, I was supposed to get a performance boost, and my performance dropped from an ASP.NET Cache object. It's much slower now because they have to serialize the object. If you have a large object, serialization is a pretty significant cost, and that's a cost that you have to incur independent of any specific cache. And as soon as you go out of process cache, your performance is much slower than a local in-proc cache. But it's still faster than the database. It's almost 10 times faster than the database, but almost, you can say, 10 times slower than the in-proc cache. So what happens is people want to gain that benefit of that in-proc cache. Well, for data that is not changing very frequently, there's a feature called client cache. Some people call it near cache, especially on the Java side. This feature, essentially, it's a local cache. It's like your in-proc ASP.NET Cache. It sits within the application process, or it can be just local out-proc cache, which is not as fast as the in-proc, but still faster than going to the caching tier. But the difference is this cache knows about the caching tier. This client cache is the cache on top of a cache. and it is synchronized. So you don't have to worry about that biggest issue that we talked about, which is how do you keep the cache synchronized with the database. Well, now you have 3 copies of the data, one in the database, one in the caching tier, one in the client cache. Of course, the client cache is a subset of the caching tier. The caching tier is a subset of the database. But whatever it is, it has to be synchronized. So by having a client cache, it is, again, an in-proc. It keeps stuff in an object form instead of a serialized form. It keeps it on your heap. So you get the same benefit of the local in-proc ASP.NET Cache object, but with all the other benefits of scalability, because this client cache will be a small subset. You can specify how big it should be. It will never cross that threshold. So you may have 1 gig in each client cache, and you may have 32 gigs in the caching tier, and the database probably has a lot more than that anyway. So even by having 1 gig, because it's a moving window, right? So as whatever you're doing, you'll keep some of the data will stay for a long time, some of the data will stay for maybe a few minutes, but within that time, you'll make hundreds of calls and not have to go to the caching tier, and of course not having to go to the database. So a client cache is a really, really powerful feature when you have that turned on. You do that for more reference data. So in case of NCache, you can specify client cache through a configuration change. There's no extra programming, but it is mapped to a specific cache. So that's why our customers typically have 3 caches: object cache, session cache, and reference cache. For reference cache, they use a client cache. For the other 2, they don't. Now, why don't they do a client cache with the session cache?
It's stateless servers.
They want to be able to move from server to server on the front end.
Actually, because the performance slows down. The reason is because this is only better if you do a lot more reads than writes. Because what happens in case of a write? You do a write here, and then you do a write here, and then you do a write in the database. So you're doing the write in 3 places. So it doesn't add any value if you have to do more writes.
In an environment like that picture where the client cache is replicated on multiple machines, are you also, when you do a write on one machine, are you going across to all the other machines?
No, so you update. I'm sorry. You update your copy, and then you update this only, and then this notifies all the other client caches to go and update themselves. It's a delayed update, not that it's only a millisecond or 2 delayed, but it's still a delayed update in case of a client cache.
Cache needs to be replicated between all web servers as well?
There's no replication between the client caches. The client cache only synchronizes itself with the caching tier, and the caching tier then propagates the updates to other client caches.
Still, it needs to be synchronized to all servers.
Only if the other cache has that data. Because in case of client cache, every client cache has different data based on your usage pattern.
Yeah, that's why I'm asking. Why would you replicate this data? If, for example, you have CD session and you have the same session working with the same web server, and client cache stays on the same working process within the same web server.
Yeah. In case of, so let's step back. In case of reference data, every client cache has its own set of data. So let's say 1 to 1,000, 500 to 1,500, and so on. So there's some overlap between each, but they're not identical copies. What is common is that they're all subset of this cache. So when I update item numbers, let's say 700 in this cache, it's going to go and update in the cache, and the cache will know which other client caches have that item. So they'll immediately be updated in the other caches, but only if they all have it. The replication, so it's not really replicated because they're not identical copies in case of client cache. In case of sessions, what I was actually trying to explain is in case of session, you will have to update the client cache and the clustered cache 2 places for no added value. Because for sessions, you do 1 read and 1 write. So at the time of web request, you do the read. At the end of the page, you do the write. So the write now has to be done in 2 places, and the read is going to be done in the client cache. So the performance actually drops if you use client cache with sessions or with other write-intensive operations. But the performance tremendously improves if you use it for more read-intensive operations. Did that make sense? Yeah. Okay.
I'm not entirely certain that you're not yes, you're losing a little bit of performance, but you're getting the ability for a session that started on one machine to now be still current on another machine, fetched from the cache.
Just
right?
imagine if you don't have a client cache at all, you already have that feature, because now every web server is going to go and get the session from the tier.
Okay.
In fact, the whole idea is that you don't want the session to be local to each web server only, because the next web request is going to go to a different server, and they all should have the same copy.
Imagine if your session cache is a gigantic blob, which is expensive to store in memory, and you had like 8 gigs on each machine. That means you need 24 gigs in a 3-server scenario to store everybody's sessions so that they're always available to all of them.
So, I mean, that's one problem. The other is performance. I mean, you'll actually become slower if you've made unnecessary copies. That's why this caching tier exists. This is already a redundant store, which is ensuring that all the web servers are going to be able to access the same session. So the biggest value of a distributed cache, the quickest and the biggest, is session state. Almost every application has it. I just created a 2-node cache cluster, and you saw how long it took, maybe 2 minutes, in case of NCache. So it's really easy to create a cache cluster. Of course, you want to do your testing and stuff, but it's really easy. There's no engineering effort. When there's no engineering effort, your schedules are much easier to deal with. You only have to do sanity testing to go through. And so I would strongly recommend, if you're going to start using a distributed cache, use it for session state in the beginning as the first step, and then jump into the object caching, which we'll talk about in a minute. So we've talked about the session caching. Now let's quickly go into the application data caching. Here's what a typical NCache API looks like, which looks a lot similar to ASP.NET Cache. If you notice, there's a connection. So you connect with the cache based on a name, and we just created a cache with a name. That's why I gave you that demonstration, so that you would understand what that meant. And this cache handle is something that you preserve just like you would preserve a database handle. You can and then you use that cache handle to do a cache.get. Every operation has a key. A key is a string in case of NCache, and then you format the key based on what you're doing with it. So in case of an individual object, a good practice is to just specify the class name, maybe the attribute name, and the value, and then you can get that. So there's a get, and get contains add async. Async means don't wait. Go ahead.
I'm just curious, the cache.get, what does that return? What's the return type on that?
It depends on so you can typecast it to your object. So actually, it deserializes it to your object type.
Well, but we're casting there, so that's what I'm saying. What's the return type? Is it an object, or is it some kind of special object?
It's just a standard object. It's just a standard object. What happens is, underneath it, there's a deserialization happening on the client end. So the client, when you do a cache.add, let's say, you're giving it an object. It's an employee object. It's going to serialize it based on either the standard .NET serialization or the custom NCache serialization, and then create that into byte array and send the byte array to the cache. NCache does more than that, because you may need to index certain attributes, so it extracts the values of those.
Sorry,
Go ahead.
if you don't implement your serialization properly, will it blow up on purpose?
Yeah, it will immediately. Yeah, so every object that you cache has to go through serialization. So as soon as you turn the application on, it's going to throw exceptions.
I've seen people do some really dumb things, so that's what I'm...
Yeah. In fact, that's a very good point. If you're using ASP.NET Cache object, you don't have to serialize.
It'll let you get away with it.
Yeah. So you can pretty much cache everything. And a lot of the time what happens is your own objects are maybe easier to serialize, but you may be using some third party. Let's say previously the data table object didn't used to be serializable. Now it is. So if you're using third-party objects which are not serializable, you have no control. So you can't cache them if you're going to use a distributed cache. In case of NCache, we have our own custom serialization where you can identify those objects, and NCache then creates the serialization code for you at runtime and compiles it in memory. So that allows you to use also those objects which are not serializable. But the serialization happens immediately, so your application will not work if it is not using proper serialization. Async essentially says, don't wait for the cache to be updated so I can continue. I trust the cache will, add this thing. So unlike a database where the updates can fail on data integrity issues, a cache does not have data integrity issues. So it only fails when you have crashes, when you are out of memory or something else happens. So you can pretty much rest assured that whatever you're adding, you're going to most likely add it into cache. So async still gives you, so it gives you further boost. So the API looks very straightforward, as you can see. We talked about.
Question on the last one.
Go ahead.
The cache remove on the bottom is returning a value. Is it like removing it and returning it?
Exactly. So if you want to know what object so there are actually multiple overloads. One is where it does not remove, it does not return anything, so it just removes it. Another overload is where it removes it and gives you that back. So in case you wanted to preserve that, So I just chose that one, but most people don't use that. Most people just say remove. So when you do application data caching, how do you keep the cache fresh? This is really, really important. There are different ways that you can cache. Expirations, almost all caches support expirations. There's an absolute expiration where you get to specify for every item, here's how long I feel comfortable for it to stay in the cache. This could be anywhere from 15 seconds to hours and days and weeks. And that's for application data caching. There's another expiration called sliding expiration, which is not for synchronizing the cache with the database. It is for cleanup. So that ASP.NET, all that transient data that we talked about, well, what happens when you're done with that data? You shouldn't have to worry about cleaning it up. So maybe that was the question that you were also asking, I think, one of you guys. So you can specify sliding expiration and say, if nobody uses this data for this long, let's say in case of sessions, 20 minutes, if nobody uses the session for that 20 minutes, remove it from the cache. So that's more of a cleanup. What are the risks in expiration? Expiration is actually, you're making a guess. You're saying, I think I'm okay with 5 minutes. But there's no guarantee that nobody's going to update that data in the database in that time. Especially if you have other applications or other processes are updating the database. So expirations are good only in limited use cases. Another very important feature is that you may have an unexpected or unpredictable updates in the database. If that is the case, then the cache should have the ability to synchronize itself with the database. So the cache should know about your database. It should become a client of your database and monitor your database for any changes. There's a feature in ADO.NET called SQL dependency. Has anybody seen that? Okay. So SQL dependency is what NCache uses to become a client of your SQL Server or your Oracle database.
Didn't they remove that though, like later on in like SQL 2014 or something?
Not that I know of. I mean, they've renamed it to database notifications now. But it's essentially the database is firing events when certain data set changes. So you can specify for every cached item, you can specify a corresponding SQL statement and say, if this data set changes, notify me. And when the cache is notified, the cache can remove that data from the cache. By removing means it's no longer in the cache. What will happen? Your application will look for it next time. It won't find it. And it'll go to the database and get a new copy. Or you can actually, in case of NCache, you can combine that with a read-through feature that I'll talk about, so automatically reload a new copy.
With the synchronizing cache with database, what about something like a view where you may be writing to one model and reading from another?
Whatever the underlying database supports is what NCache will use. So in case of SQL Server, you can use the SQL dependency is a SQL Server ADO.NET feature that NCache uses to get events from the database. If you don't have events,
So you still have to wire up the event to bust the things that. Okay.
yeah. So the cache NCache becomes a client of your database. It receives events, and then based on that, it does its own thing. In some cases, you don't have events. So let's say if you had DB2 or MySQL, they don't have events. So then the cache should be able to do polling. NCache also supports a polling-based. So you do the same thing. You cache this item in the cache, and you said, this maps to this row in this table. And then NCache will do the polling. And then if that data changes, it will, again, either remove it from the cache or reload a new copy. But this feature, it gives you a lot of comfort. Again, that same thing that I was talking about, which is that you want to make sure that cache is always synchronized with the database. Expirations is good enough for only a small subset of the use cases.
Can you have SQL dependent entries also expire, or are they always guaranteed to be available? In other words, will you ever get a cache miss if it's something that's SQL wired up with the SQL hook?
So actually, you will get a cache miss if you don't do an auto reload. So when the SQL dependency fires up, NCache removes the item from the cache. So if your application then wants it, it's going to be a cache miss, and then you'll be forced to go and get a new copy from the database. If you don't want a cache miss, which is in many of the e-commerce applications, because they're reading data so frequently that they don't want anything to increase the load on the database. So you would actually use the SQL dependency with this feature called read-through. I need to actually show you some code, otherwise it starts to get very boring. So let me quickly show you. So I have just a very simple console application. In case of NCache, all you have to do is add some assemblies here. So there's ncache.runtime and ncache.web. Then you specify some namespaces, these two, and then you connect to the cache, and you got your cache handle. And then you create your object, and then you do cache.add. And you specify key. This is not a good key. I meant to change it. But your key should have the actual value in it. So you do a cache.add, and you specify the object. In this case, I'm also using an absolute expiration of 1 minute. So you specify the absolute expiration, and that's it. That's all you do to add this to the cache. Next time you need it, you'll just do a cache.get, specify the same key, and you'll get the object back. Very, very straightforward for an absolute expiration. You could do the same thing for a sliding expiration, although instead of specifying an absolute value, you have to specify an interval, like 10 minutes or 20 minutes. SQL dependency is what I wanted to show you, what it looks like there. So same type of an application. You just need to add these two here, and you specify the namespaces, and then when you go and add the stuff to the cache, that's when you specify SQL dependency. Let me just go to the definition of it. So I'm going to be adding this to the cache here. So I've got my key, which is what I showed you last time. Now instead of adding the object, I'm going to just add a cache item. And within that's an NCache structure. So it stores the actual object. And it also stores a SQL dependency. So NCache has a cache dependency object. So I do a new SQL cache dependency. That's an NCache class, which internally maps to SQL Server's SQL dependency. So you pass it a connection string, and the connection string is your SQL Server connection string, and you pass it a SQL statement. So here in my case, I specified select this where product ID is whatever my value is. So I'm just mapping it to one row in the product table. And by specifying this that much, I have now just told NCache to become a client of the SQL Server and remove this item if this row changes in the database.
It's row specific.
So it depends on what the SQL statement is. So if the SQL statement contains only one row, it maps to only one row, then that's what it's going to be. Usually you can't do joins in this. And that's a limitation of the SQL dependency feature in ADO.NET. But for a single table, you can easily do this. So that's how you would do the SQL.
So you're saying the SQL dependency can only be one single table?
As far as I know, yes. As far as I know.
So a view would be a case where it wouldn't work because a lot of times you're doing a lot of joins.
If it's a multi-table view, yes.
How is it implemented?
Huh?
SQL Server side, how is it implemented? How is SQL Server verified?
So SQL Server has this thing called SQL Broker. So it actually creates a data set, or a data structure on the SQL Server end to monitor these data sets. So all the SQL dependencies that you create, SQL Server creates data structures to go and monitor the data sets. And based on that, it sends you a SQL notification.
In old days, it was pretty kind of flavor intensive to pay the notification. So is it done automatically when you subscribe?
No, so you do have to configure this on the SQL Server end. Yeah, yes, because it's a security thing also. So your DBA has to get involved in configuring the SQL Server, but it's pretty straightforward. I mean, there's no programming or anything needed on the server end, just a configuration. All the stuff is taken care of by the client side. Okay. So we've done the SQL dependency. I wanted to show you, so if you don't want to remove this item from the cache, you can do a reload through a read-through. So read-through is another very, very powerful feature. Read-through is a server-side code. So actually, read-through is your code that runs on the cache cluster. So you actually register your code, and it runs on the cache cluster. It is called by NCache. And the value of a read-through, and let me first show you what read-through looks like, and then I'll show you what the value is. I mean, why do you want to do the read-through? So here's what a typical read-through looks like. It's an iRead-through interface. You do an init so that you can connect to your data sources. You do a dispose, of course, and then there's a load from source. It passes you a key, and it expects a cache item back. So cache item contains your object and a bunch of other things, like you can specify expirations and other things inside it. Very simple interface. This is called by NCache. So you implement this interface, and you register your assembly. In case of NCache, you register your assembly with the cache. And now, when you do a cache.get and that item does not exist in the cache, NCache will call your read-through to go and get it from your data source. Your data source could be a database, it could be a mainframe, any data source. So by having a read-through, you can ensure that the cache always has the data as far as what the application sees. So that's one benefit. The second benefit is the reload. So you can actually combine read-through. So you can on expiration and database synchronization. When the item was otherwise going to be removed from the cache, and you don't want it to be removed because you're just going to reload it again anyway. So why not have the cache reload it for you? That way, because if you just think of this, you've got millions of items in the cache, and they're all expiring all the time, right? Because that's how you've configured it. If and you have an e-commerce and a really high traffic application, and every time something expires, you have a lot of simultaneous requests for it. They'll all go to the database. So suddenly the database traffic has gone up for no reason. Even though you're going to need it in the cache anyway. So since that keeps happening all the time, you'll see a lot of spike in the database traffic despite having the cache. So that's where by having a reload means that it is never removed from the cache. It just gets updated. So your applications will never go to the database. They'll keep getting the old copy up until the point that you update it. So you've suddenly removed or taken care of that issue where even though you had the cache, you were seeing a lot of spikes in the database traffic because of the expirations or the database synchronization. So by having the cache reload this to the read-through really makes it very powerful. The other benefit of the read-through, of course, is that you're simplifying the application tier because more and more of the database access is done by the cache. So if you have multiple applications, accessing the same data, you can truly centralize the data access within the caching tier. Of course, you can't do it for all data, but for a lot of the data you can. Write-through works in the same fashion as read-through. Let me just go to the write-through. It works in the same fashion. It's got a write-through provider, again, init, dispose, and now instead of load, it's a write to data source, and it's got another, like a bulk write. Write-through, one benefit is the same as read-through, which is you centralize everything. Second benefit is that you can do a write behind, which is that you update the cache, which is, as I said, 10 times faster than the database, and then you ask the cache to go and update the database. And the write behind is essentially the same as write through, but done in an asynchronous fashion. It's a queue that gets created, and it gets processed. That queue is also replicated in case of NCache, so none of the updates are lost if any one server goes down. But the write behind really speeds up the application because, you've already made it faster by caching to doing all the reads, right? So about 70 to 80% of the reads are now, or the transactions are going to the cache anyway. Why not also speed up the writes? If you can do it in a write behind fashion, if you can afford to do an async write. If the data is too sensitive, where you cannot afford, then you do a write through, then you only get the first benefit, which is centralization of the code. The second benefit of faster performance comes only if you can do async.
So I guess the thing that is usually the easy part is when you have one table. The hard part is when you have two. And so like in the event of like, let's say you have an application that's maybe like an inventory application and you have work orders, right?
Right.
And the work order needs to change inventory. What methods, how do you do that same thing? Because like your example is a simple example of a single table, but now you need to know, okay, well I have a query that I have one query that has inventory, I have one that has work orders, then I have yet another query that has inventory and work orders at the same time. When I change any one of these two, I need that third one to be updated and vice versa.
Right. Well, that's where you can use other features. And because of the shortness of time, I didn't go into it. There are also other ways that you can do what is called cache dependencies. So you can actually create relationships. In fact, somebody was asking me this question earlier today at our booth. How do you create dependencies? So there's a cache dependency feature, which is also an ASP.NET Cache object feature that NCache has implemented. And that you just say, you tell the cache, this depends on this depends on this, and the cache then knows that if this is updated, it automatically removes the other items from the cache. So that helps you ensure that if there are multiple copies of something, or there's some relationship where this thing shouldn't really exist in the cache. If this thing doesn't exist, then you can create those dependencies.
And then I noticed the one note that you have at the bottom there is one-to-one and one-to-many. What about many-to-many?
Many-to-many, from an application perspective, is always one-to-many. Just think about it. If you have multiple many-to-many, you'll either access things from this angle or from this angle. So if you have a product and, I don't know.
But if let's say you have a multi-tenant application and you're querying data about two tenants, that is two one-to-many relationships, right? So you essentially have a many-to-many. Like if something changes about customer one or something changes about customer two, you have one query, so you have to somehow bust that. So it's still many-to-many.
Yeah, actually, there's a lot that we can talk about. There are a lot of techniques, but in case of NCache at least, it lets you handle all those relationships so that you can keep track of. In certain types, you want to cache the entire collection as one object. Sometimes you want to break it up into separate objects for that specific reason where.
So is it like is your example more like a one-to-many kind of?
Yes, and then what you do is you break up the many side into individual objects, because if you anticipate that they are now going to be part of the one-to-many backwards, and if they get updated, then you want to make sure that they are updated correctly. So there are a lot of different ways that you can do. The whole idea is that when you start to do caching, don't think of a cache as just a simple key value pair. I mean, my whole purpose of this was first to convince you that you really need a distributed cache as part of your infrastructure and the application architecture. If you want the applications to scale, you must incorporate this, independent of which caching product you use. I mean, you should have it. Currently, for .NET folks, the options in the market are NCache, which is an open source, and also commercial. There's Redis that Microsoft has made available on Azure. At least on Azure, it's a managed cache service. Outside of it, you have to install it, and it mainly installs on Linux unless you use the open source unsupported version. On the Java side, there are a lot more options on the caching. But so that was the first goal. Second goal, you should understand that it's not a simple key value. You want to make sure that you can cache all sorts of data and handle all sorts of situations. That's where you get the real benefit. And I haven't even gotten to the other part, because I'm actually running out of time, which was, for example, how do you do runtime data sharing? And what are some of the architectural things that you want to make sure that the cache is always dynamic so that you can configure things. It's part of your data center. It's part of your production environment. So any cache that does not let you make changes at runtime is not a good cache to pick, because then you'll be stuck with a lot of downtimes. Then, we have customers that have scheduled downtimes once a year. So some of our customers don't even have that because they have such a high availability. They want to even upgrade the cache itself, a new version, without a downtime. So, I mean, it depends on what are your business requirements, but all of those things have to be factored in. A lot of people have multiple data centers now, at least for DR purposes, and then also for geographical load balancing. If you have that, you expect your database to replicate, right? So why shouldn't the cache be able to support multiple data centers? Because the less a cache can do, the more you'll have to do. That's the bottom line. Because your application needs will not change. The cache has to accommodate. So keep all that in mind. And I'm going to, so there's a comparison between NCache and Redis. They're both open source. NCache also has enterprise edition, so do they. NCache is basically, if you're a .NET shop, NCache fits in very nicely. The N in NCache stands for .NET, bottom line. I mean, that's how committed we are to .NET. That was the marketing part. I'm just going to quickly show you our website just so that you know. So we've got NCache, and we also have a product called NOSDB. NOSDB is something that we launched recently. It's starting to get a lot of traction. It's an open source NoSQL document database. And the reason we did this is because we've been in the NoSQL space for the last 10 years. We just don't call it NoSQL. We just use the word distributed cache. But it's really a NoSQL in-memory key value store. When you use the word NoSQL, there's a key value store, there's the actual document database. So we are now covering both ends. And it's open source, again, much more feature-rich than other options.
So does NCache uses NOSDB inside?
Actually, NOSDB it's built on top of NCache architecture, but they're solving two different problems. NCache is for more in-memory stuff to work with your existing databases. NOSDB wants you to. Sorry. NOSDB wants you to move your data into your NoSQL database. That same thing that I talked about. A lot of customers are moving to NoSQL database for some of their data, not all of it. So NoSQL is not going to replace relational. That's a sort of side talk. But so go and take a look at it. And I have everybody's name, so I will email you a link to the presentation. Thank you very much.